we go.
Okay. All right. Hey, hi there. Hey, welcome once again to Destination Space, a series of incredible talks by NASA engineers and scientists. Today, today we have Mr. Eric Aguilar. He is the Assistant Product Delivery Manager for the Mars 2020 Sample Caching System and the Mars 2020 System Testbed Manager at NASA JPL. Remember, the Jet Propulsion Laboratory, JPL, is in Pasadena, California, right near Los Angeles. Mr. Aguilar will be discussing how the Mars sample caching system will operate on the surface of Mars and some of the challenges faced during development. Mr. Aguilar has participated in the development of avionics and system testbed, Mars exploration rover, avionics, design for the Dawn spacecraft, system testbed manager for Mars Science Laboratory, and the technical group supervisor for system integration and test group. Again, I'm Andres Martinez. I'm an engineer with NASA here in Silicon Valley. And once again, thanks for coming. Mr. Aguilar, can you please go ahead and begin your presentation? Remember, there's only one rule for all of us, okay? All of us are going to mute our mic, and then at the end of Mr. Aguilar's presentation, we will have a question and answer your questions, all right? All right, thank you.
All right. Hey, welcome, students. My name is Eric Aguilar, as you guys just heard, and you know, one of my jobs was to manage be an assistant delivery manager for the Mars 2020 sample caching system. So I'm going to talk a little bit about that system today. That system is actually this most of the front end of this rover which includes the robotic arm, the coring drill, and then the adaptive caching assembly that's inside. And then at the end of the presentation, we'll have a video showing some of the testing that we do that's end-to-end, and that we do in our 10-foot space simulating chamber. All right, so let's jump forward. So, you know, why, you know, what do we want to we want to answer the question on Mars, you know, at Mars is, was there ever any life, right? And in order to do that, you know, we had to come up with a system not only of science instruments to allow us to help detect, you know, microbial life or potentially detect that, you know, signs of life. We wanted to also, you know, take these samples and get them out of the ground, store them, and then eventually, you know, through a return mission that would be made by NASA, is to actually bring them back to Earth for further study, right? So that's partly what the sample caching system is to actually get samples, take it out of the ground, you know, rock samples out of the ground, and then store them, you know, seal them, and then store them, and then eventually wait for another mission to pick them up and return them. So what does that mean, right? So there's a lot of reasons why we're going to Mars with Perseverance this time. One is to, you know, study the geology and the astrobiology, but one of the main samples, or one of the main objective is to do the sample caching, right? And that's again, that's what I'm going to talk about today, right? And we're going to talk, and you'll eventually see what the final design ended up of. You know, this was an early concept of what the tubes might look like, and you'll see eventually what they look like and what a rock sample looks like inside. And then, and in addition to that, we did take some instruments with us to actually help with, you know, for human exploration on Mars. So that's something that is also a goal as part of Perseverance. All right. So here's where we're at, right? So we want to take rock samples, right? So and we want to store them on the surface for potential return, right? So we actually use the rover. The rover is a mobile geologist, if you will, right? So he or she, actually, I think we go by she. The rover will actually go off and um, you know drive around using imaging and cameras and radars to help determine what are some interesting areas to further investigate. Once that's determined, we'll then use a variety of instruments, whether it's remote sensing in the sense of a laser, where a laser will be fired at a rock, and then a second laser will be used to measure the dust that has comes out of the rock, and then we'll determine if that's something that we would like to go explore further. And then we have other instruments at the end of the robotic arm that will help us do what we call contact science and actually take measurements and again see if that's something that we would like to do. And so in doing that, right, we're gonna understand what kind of rocks we want to get to and explore with further detail. And those are the ones that we're gonna take a sample of and cache. And cache is another word for store, right? So we're gonna sample and store rock samples or kind of a loose sand as an option as well. Let's see. So the rovers from MSL, which is Curiosity, and Mars 2020, which is Perseverance, they're pretty much the same. They're about the same, right? They're still a fairly big rover, the size of an SUV, about 2,000 pounds when it landed. And but one of the main differences is that we made some pretty big upgrades to the coring drill, and then all the adaptive caching assembly stuff inside, right? So it is equipped with a set of new tools. The coring drill is probably 1.5 times, so it's actually almost twice as big as a previous drill on MSL. And the arm, we actually were able to make the arm a little bit lighter than we on 2020 than we did for MSL, and that helped us make the drill bigger. So we were able to really try to engineer and fit in as much of new tools and new concepts to this rover. All right, so here's a little video of the rover doing a bicep curl. Let's see. And in this case, right now, it's actually working its way, and it's stowing the arm for the launch position. So once it gets locked into place, that's why all the engineers are checking, because it is a really, really tight. It's a really tight fit when it gets in there. And you see the big arm out there. The big arm is roughly about 75 kilos, or close to 150 pounds. And it stretches out at about 7 feet. Now that's pretty big, right? But one of the other primary things that's inside the rover is a smaller arm, and that's called the SHA, the sample handling arm. And that one is used to actually process all the tubes, whether they get a fresh tube and get it ready for a sample, or after a sample has been taken, to actually process the tube and verifying how much sample we collected from the ground, and then what do we do as far as getting the seals and getting them activated, and then storing them for future drop-off activity. So in there, right, I mentioned there's a small robotic arm, and there's also the rest of the system in there, which is a big carousel, which is actually one of the things that you can see in this blue circle. This is a big carousel that actually we are taking multiple bits, because when you're dealing and drilling with rocks, sometimes the bits might get dull if the rock is really hard. So we actually take extra bits with us, and that way we're ready for just about anything that Mars may throw at us, right? So also additional innovation that we have here. And this is just another cool picture of the of the brick carousel and the adaptive caching assembly getting ready to go inside the rover. This is like I said, the big carousel which holds all the bits that will eventually be drilling into the ground. As you can see, everything's a really tight fit with the rover, and we had engineers and technicians, working many hours just trying to get this thing all lined up and put in there and ready for flight. So these are our pictures from our ATLO floor, which is the assembly, test, and launch operations area. Okay, so why are we going? Why are we looking for microbial life, in the places that we selected, right? So as I mentioned, right, we want to go and pull out rocks and do that. But, we understand that, like on Earth, right, we know that microbes are everywhere, right? They're all over the place. And so, but we also know that, it's also available, microbes are living organisms, right? So we want to see that those and living organisms tend to be around water. So we actually think that there was water, right, back on Mars, a lot of flowing rivers and lakes. And so, and it's been dried out since. So now we're trying to go into old lake beds, old reservoirs. In this case, we're going into Jezreel Crater, which looked like it was a lake that had an input and an output, so it had a lot of water flow through there. And now we're looking to see if we can actually find microbes that were left behind in the rocks, and that's why we're there, and that's why we're looking for signs of life on Mars. And like as I mentioned, right, once we pick up these samples, we're gonna store them inside the belly of the rover, and we'll eventually bring them out for a future mission to return. Right, I believe they've already started that mission, and they've already started at least thinking of the concepts of how to pick up the samples and bring them back. So that's something that's we're all pretty excited about, and perseverance is step one to that. So what happens, right? We're looking at getting rock samples back, right? So when they come back, it's going to be one of those things where it'll get back to Earth, and as far as I understand, we're going to get it to one of our NASA centers. And I think they're still trying to determine which center is going to hold these samples. But one of the centers will actually hold the samples. And then scientists will potentially come down and study the samples at NASA. Or there might be options for us to send samples to other institutions or other universities or laboratories to actually do that investigation further, right? So, that's one of the exciting things is not only the work that we're doing now, it won't be actually shared probably for almost a decade, for almost 10 years from now. All right, so I'm gonna jump out of this presentation for 1 second here, and then we're gonna go to a video. Let's see, maybe I closed it by accident. Give me 1 second. I'm gonna stop my video I'm gonna stop my sharing for 1 second here. Okay, hang on. All right, hopefully you guys can see this. I'm sharing my video here. And what we're going to see is actually one of our it's a 5-minute video. It is sped up, and you'll see that it's sped up on the bottom of the screen. It'll tell you how fast it's going. But we actually are able to, we put in 10 cameras into a chamber, and we were able to videotape an entire end-to-end sampling operation. And this is for you guys to see, and I'll try to narrate as we go through. Okay, as we mentioned, this is a coring end-to-end as part of our qualification model dirty testing. And so we're in the chamber now, and the small robotic arm is now moving into place. It's getting ready to go and grab a sample tube out of its storage. And as it moves up to grab a tube, you're going to see it now. Pull it down in a second here. So here we go. It has the tube, and now it's moving it into and putting it into the coring bit, right? So now we're preparing the coring bit to be ready to go take a sample, you know, from a rock. Okay, so that's what we did in this one. So that was that operation that just happened. Now it goes and it kind of puts itself and it kind of waits for it to be ready to come back, right? So now you can see the big carousel moving, and it moves the bit out to the front for the robotic arm to pick up the and the drill to pick up the bit with the sample tube inside. We then undock from the rover and we move ourselves into position to interact with the rocks on the surface. So we're going to use what they call the facility contact sensor here, and that's a sensor that's going to touch the rock, and it allows us to make sure we understand how far the rock is from our robotic arm position. So we use that as a way for us to, you know, get an understanding of the world around us. Okay, there you go. Now you see it. It's starting to get ready to drill a hole inside the rock, and you can see that happening. There you go. So now it's gone in. It's drilled. It broke what we did. It did a core break, which is it breaks the core off from the inside of the rock, and it gets it trapped inside the tube and inside the bit. Now it's doing a series of poses where it's going to take some images. You can actually see the rock inside. You can kind of see the rock inside the bit there. Now we do one of our operations, what we call percuss to ingest, which is just to make sure that the rock sits at the bottom of the tube. We take another picture. And then we go and we dock with ourselves with the rover. As we come in, we dock, and we are going to now drop off that bit and the sample tube and the rock all together in one motion here. Okay, once we do that, we will then spin the carousel, and now we'll be inside the belly of the rover again, right? So now we're back in the belly of the rover, and our small robotic arm inside will now take out that tube with a rock sample inside. And as you see it going in there, it's going to go and get ready to take out the rock sample, and now it's going to go and measure the volume. It's going to go use a volume probe to actually determine how much of the tube or how much of the sample is in the tube, right? And then we'll go and grab a seal. And everything has a cover, so we have to uncover things and then get it ready to go, right? So, but here you go. Here's the tube. Here's the tube coming out. Now we'll take some images. We'll flick off any dust that we may have accumulated over during the drilling operation. And then here's where we go to the volume station these are the very stations I mentioned before. The volume station is where we measure how much sample is in the tube. And then we'll go with the seal dispenser. We'll go grab a seal from the seal dispenser. And then again, now you see that there's a seal on top of the tube. And then we'll go over to the sealing station where we will activate the seal with the ram. You see the ram coming down, it activates the seal. And then again, we take a lot of pictures. We take a lot of pictures inside the rover to make sure that we understand how this thing went together. And then we put the tube back in its storage for for a later date to drop off, where the scientist and the operations team decide that they want to leave the sample tubes for the future mission to come and pick up. All right, and I think this just about ends. You know, you can kind of see how it's now cleaning up all the coverage that it took off, and it's getting ready to you know, put itself store itself for us to drive around again and go find another sample, right? So here you go, get in the extended stow, and then we're done. So that was that one. And then I just want to get back to here. And so, you know, one of the cool things that you're going to see is this is actually one of our test images where we took a image. Now it looks kind of funny because you can see it's broken up into four quadrants here, and each of those quadrants were different exposures. We were sort of playing with different exposures to see what's the best exposure for capturing the rock. Normally we would figure out the exposure once and then take all the images with the same exposure, and then you wouldn't get these kind of funny colors, and then we'd stitch it all together and it would be one picture. But this allows you to see inside that tube and to see the rock that's there. And this will be information for the scientists to know that there's a sample in the tube and that they're going to want to pick that one up later. All right, and then those are my slides. So if we have, you know, comments, questions, I'd love to hear from you guys. You know, you can always use these, you know, the mars.nasa.gov/2020, Mars 2020, to also get some more information. So I guess, should I stop sharing here? I think I'll do that.
It is up to you.
Okay,
and I do want to say thank you, Mr. Aguilar. This was an amazing presentation, especially getting to see some of these behind the scenes videos. So it looks like Miss Moeller from Lindale has a question. It looks like she has one of her tiny coworkers with her and who wants to ask a question. So if you want to go ahead and unmute yourself.
Hi, hey, thanks for taking our question. So this is my daughter. She's in first grade, and we've been listening to the talks throughout the month of February, and I have a lot of my students that have joined today from Lindale. So thank you. First of all, Olga, this is fantastic. This is just really overwhelming and amazing. So I have a couple of questions for you, Mr. Aguilar. I wrote down a couple of things. I hope you don't mind. So just a couple of quick questions. About how many samples will be collected total? And then part B is about how many areas will you be collecting samples from? And my next question is, do you have now? Oh, okay.
Where's the helicopter now?
So the helicopter is still in the belly of the rover, right? We haven't dropped it off yet. So there's I think maybe in a week or so, we may be dropping it off on the surface. Right now, it's still tucked away in the belly where it was when we launched and when we landed. To answer some of your mom's questions, you can get to your third question in a second, but the first question is, we are taking 43 tubes with us. And so, you know, I'll say that there's two things here to think about, right? 43 tubes is what we take with us. You know, 37 is the number that we're supposed to be able to sample and cache. So that tells you that we have what could be considered, you know, an engineering failure. Maybe we didn't get enough sample or whatever, that, you know, up to 6, right? And still be considered a success. And then as far as I understand, I think it's 27 sample tubes are coming back. So there's a bit of a down selection, as you can see. So, but we are taking 43 tubes. Our expectation is that all 43 will get filled with either sand, like loose dirt, gravel, and or rocks. And then where are we going to sample, right? We're starting in Jezero Crater, and we're going to kind of make our way out to the rim of the crater. And then, you know what, to be honest, between the helicopter and what images that we get on the ground, we'll know more where we want to sample, right? It's not, we have an idea, we have kind of a driving path that we plan on taking, but that doesn't mean that we won't divert and, you know, we won't decide to do something else. So right now we have an idea. We don't necessarily have a solid, this is exactly where we're picking up samples right now.
Fair enough. And sorry, one more question. do you guys have any idea what you expect to collect from the surface of Mars? I mean, do the scientists basically know what they're expecting back, or is this going to be a complete shock, or is there just like?
Well, yeah, I mean, right, we're looking for microbial life, right? So or evidence of past microbial life. So, you know, the idea is that we don't think that there's anything actually living right now, like physically living, but we think that there might be some microbial, for lack of a better term, again, I'm not one of the scientists, right? But, you know, like the outer shell or like the skeleton of this, right? Of this, you know, microbial, you know, life, right? So we want to go, and I think that's what we're looking for. I don't know that anybody can say exactly what they think they're going to find when the samples come back and what to get, right? And part of bringing the samples back, right, enables more scientific investigation, because the samples typically, right, if you're going to go to Mars and you have to then put your science instrument onto a rover, it needs to be effectively miniaturized, right, to fit on the rover with everything else that's going on there. A lot of these instruments that we have on Earth are really big racks and a lot of, you know, electron microscopes and all these other, you know, things that just require space and weight and power that we just don't want to be able to put on Mars. So bringing them back, you know, enables all that extra work to happen.
Thank you so much for taking our question.
Yeah. Is there another question?
It looks like Anthony Delgado has his hand up and wants to ask a question. So Anthony, if you'd like to go ahead and unmute yourself.
Where's the rover right now?
So the rover right now is in Jezero Crater. It really hasn't moved from when we landed. One of the first things that we did when we landed is we had to deploy some of the cameras. We had to deploy the antennas. We had to get ready to sort of start taking images so that we can understand what's around us, and decide where do we want to drive to. But we're also doing a lot of checkouts, what we call our commissioning phase. So imagine that you've been traveling for, you know, 9 months, or 8 months, almost 8 months from Earth to Mars, and everything was all tied up and bundled up. Now you're on the surface, you're kind of stretching everything out. So now we're giving the rover a stretch, and we're checking that everything survived, not only the launch, but also the landing and the entire travel over there. So we're just right now what we call our commissioning phase, and then we're updating some software, and then we'll start an initial drive. I think in the next few days or so.
Okay, so we're going to go ahead and take some questions from the chat. So one person wants to know, if there's oxygen on Mars, then will we still have to wear a suit? And following up on that, how do you make the deadly air into oxygen? Yeah,
so good question. So there is traces of oxygen in the air, right? It's as part of the carbon dioxide, right? That's part of the chemical mixture that makes it. It is not meant for normal human consumption. It is, like, as you mentioned, deadly, right? And so we actually do have an instrument on board Perseverance, which is it's called MOXIE, and MOXIE is it's basically, it takes that carbon dioxide, and then it runs it through a process internally. It's very a process that requires a lot of heating, and then it separates out and gets the oxygen and pulls that out, and creates, you know, oxygen that we could breathe. So this is and again, as I mentioned, right, with the instruments, they have to be, or these payloads we call them, they have to be smaller and sort of miniaturized. And so this one has a version of this on there. And the idea is that if we can, once we get there and we can make these experiments and understand how much flow we can make, how much oxygen we can make with the smaller instrument, we think that we can actually make a bigger one for like humans to be there, and, you know, potentially like inside of a hab, like a tent, if you will, that we can make oxygen for people to breathe, and then they won't have to wear their spacesuit all the time. But yeah, you will still need your spacesuit now if you go outside and don't have the the oxygen around you, keeping you safe.
Okay, so we're going to ask one more question before we get back to the students. So you had mentioned in your presentation that both Curiosity and Mars 2020 Perseverance look pretty much the same. So have the engineers at JPL started thinking about what the next iteration of the Mars rover will look like? And following up on that, do these rovers run on batteries?
Yeah. So yes. So let me start with the battery question first. So yes, the rovers do run on batteries, but they're charged. So we keep charging them with what we call a RTG, which is a radioisotope thermoelectric generator. It's a big word, a lot of words there, but what it tells you is that we use the decaying a decaying nuclear source, which gives off a lot of heat, and that heat, as it decays, we take that heat and we use what we call a thermocouple or thermoelectric device, which takes that heat and as it cools down, generates a current, and that current is then fed into the battery. So we use this RTG, which is basically always on and always generating power to constantly keep the batteries charged. And so, but as we use the rover throughout the day, the batteries start to kind of deplete. They start to get low. So we actually have to tell the rover, okay, and because it gets dark, right, and we can no longer image because we don't have any light to actually take pictures with. We then tell the rover to go to sleep, and that helps charge the batteries, and then wait for the sun to come up the next day, and then we start our day again. And yeah, so the next rover, at least the initial concept that I've seen is the next one is the one that's going to go and pick up the samples, and we're calling that the Fetch rover. That rover is going to be much smaller than we have on between Spirit and between Curiosity and Perseverance. I imagine that rover will look a lot more like Spirit and Opportunity, where it's maybe a golf cart size rover, because one is when we land, we also have to take with us the MAV, which is the Mars Ascent Vehicle. This is a rocket that'll come back to Earth, and we have to manage how much weight we're taking and putting on another planet. Our technology for landing, heavy payloads as like the rover is going to be constrained. So that's what we're looking at right now.
That is pretty cool. So it looks like we have time for one more question. I know Elena, you had your hand up, and I wanted to go ahead and invite you to ask Mr. Aguilar a question.
If there are 5 rovers on Mars, how many are still alive?
I want to say 2. Yeah, it's 2. So the Sojourner, right, which was the early Pathfinder mission. That one eventually, that was a solar panel. The 3 solar panel rovers, right, the Sojourner, Spirit, and Opportunity. All those are the ones that have now no longer have any power, so they're no longer alive and running around. So the last 2 that are running are Curiosity and now Perseverance.
Thank you so much, Mr. Aguilar, for joining us during your lunch break. And before I hand this off to Mr. Martinez, I just wanted to have everyone give you a virtual round of applause as thank you as we continue this amazing journey and learning about the Mars 2020 mission. So I'm going to go ahead and hand it off to you, Mr. Martinez, so we can get these wrapped up.
Oh, Mr. Martinez had to go to another meeting. So we want to make sure that all of you know that next Tuesday, March 2nd, we will continue with more presentations. Okay, March 2nd, Tuesday. So we wanted to thank all of you for participating with us. We really appreciate all your time. And let's give Mr. Aguilar one last round of applause. Thank you, virtual round of applause. And we really appreciate everything that you've said, and our students are getting to be engineers, experts, and we want them to go and work over there with you and here in Silicon Valley. So that's the main reason why we're doing this. So come on, Mr. Aguilar. Aguilar needs help, okay? So let's make sure that that you're all doing all your work and getting all enthusiastic with science and math and all the other subjects that you love. Okay? Thank you, everyone. We'll see you next Tuesday.
Excellent.
Anything
Thank you,
else,
guys.
Mr. Natividad, that you want to say anything else?
No, that's it. And like I said, we're excited to have you guys connect with all these wonderful professionals here. And whether it's building Legos or getting ideas, you guys have awesome questions. I'm sorry we can't respond to all of them in the chat, but remember, you could always Google search those information pieces. And we're going to be learning more about the Artemis Project coming through next month as well. So same link, same time, Tuesday, Wednesday, Thursday. Please come back because we love hearing from you and we love learning from everyone all together. You all take care.
Thank you, guys. Bye.
Thank you, Mr. Aguiar. Appreciate it. Have a great one.
Thank you, everyone.